Have you ever imagined a world where instead of waiting months or years for a donor organ, a doctor could simply press print and create a brand new heart, liver, or kidney? Not from plastic or metal, but from real, living human cells. It may sound like something out of a science fiction movie like Star Trek or Iron Man, but this is no longer just a futuristic dream. This is the emerging reality of 3D bioprinting, one of the most revolutionary innovations in medical science today. Every day, thousands of people around the world wait anxiously on organ transplant lists. For many, that wait is a matter of life or death. The sad truth is, there just aren't enough donor organs to meet the need. And even when a match is found, there is still the risk that the body will reject the new organ because it is seen as foreign. But what if we could eliminate those problems altogether? 3D bioprinting offers a potential solution, one that is as bold as it is brilliant. By using a patient's own cells to print a living organ, scientists could create personalized, lab-grown organs that are biologically compatible. That means no more donor shortage, no more waiting lists, and most importantly, no more rejection. This technology has the power to completely transform the way we treat organ failure. It could extend lives, improve outcomes, and reshape the future of healthcare. But how does it actually work? What kinds of organs can we print today? And how close are we to printing a fully functioning human heart or kidney? Today, we'll dive into this exciting frontier of science and medicine to discover how 3D bioprinting may soon give us the ability to build life layer by layer.
Now we look how the bioprinting are working. So at the core of 3D bioprinting is a groundbreaking concept, building a functional living tissue using bioink, which is a specially designed substance composed of living cell and biocompatible material like hydrogel. So this technology enables scientists to construct tissue and organ layer by layer following a precise digital design, much like how traditional 3D printer work with the plastic and metal. So one of the most advanced technique in this field is called flash printing, which is stand for freeform, reversible, and within of suspended hydrogel. So in this method, bioink are printed inside a supportive gelatin-based bag that hold the soft structure into place during the bioprinting process. So after the printing is completed, the support gel is gently removed, leaving the behind delicate and complex 3D biological structure. This technique is particularly useful for printing soft, intricate, and delicate tissues like those found in the heart. Researchers research have used 3D bioprinting to successfully recreate organs such as myocardium, the muscular layer of the heart that translate to on the blood. So they have also printed vascular network, which are essential for delivering oxygen and nutrients to keep the tissue alive, just as a blood vessel do in human bodies.
Let us go through and take a closer look at what had already been accomplished. So, first and foremost, one of the most challenging organs to print is the kidney. It is due to it is incredibly complex with millions of tiny units called nephrons, which are the functional units. These nephrons consist of each containing glomeruli and also tubules. Researchers have already printed glomeruli, which are the filtration units and also the tubules, which mainly functions in reabsorption of essential substances. The current goal and main goal is to eventually print the entire functional nephrons, which could make into a kidney. This could be the future for kidney replacement in patients with kidney failure. Other than that, the lungs also present another challenge. It is due to their delicate alveoli and also complex airway structures. But as technology advancement, progress has been made in printing the lung tissue model, which may one day support patients with respiratory failure. Apart from that, 3D bioprinting also holds a promise for treating diabetes. Scientists had successfully printed pancreatic islets, which are clusters of cells which produce insulin, which mainly in diabetes, this insulin hormone is mainly impaired. So, in the future, this could offer a new treatment option for type 1 diabetes. And even before full organs are ready for transplant, 3D printed tissues are already being used in the lab nowadays. So, pharmaceutical companies have used the printed tissues to test on new drugs, which reducing the need for animal testing and improving the safety for patients, as the 3D bioprinting tissue eventually replicates how our tissue in our body function, and the structure replicate the structure of the tissue in our body.
3D bioprinting is more than just an exciting scientific breakthrough. It represents a profound shift in the future of medicine and in the way we think about healing. Imagine a world where no patient has to wait on an organ transplant list, where hope isn't limited by blood type or donor availability, where rejection, immunosuppressive drug, and long-term complications are no longer part of the conversation. Instead, organs are tailor-made, custom designed from patient's own cell, perfectly matched and ready to restore life. That may sound like a dream, and in some ways it still is. But every year, that dream ages closer to becoming reality. Today, scientists are printing functional tissues, repairing damaged organs, and pushing the boundaries of what regenerative medicine can do. Of course, there are challenges, technical hurdles, ethical concerns, and the need for strong clinical evidence, but the momentum is undeniable, and what's more, the impact could be global. Think of the lives that could be saved, the suffering that could be eased, the families that could be kept whole. 3D bioprinting is not just a tool for innovation, it's a symbol of what we can achieve when science, compassion, and imagination come together. With continued research, thoughtful collaboration, and responsible leadership, we are building a future where healing isn't limited by scarcity, but driven by possibility. The road ahead is long, but the potential is limitless. And one day, maybe sooner than we think, the technology will no longer be a futuristic concept, but a life-saving reality for millions.